Welcome everyone that's here. This is the webinar for writing conclusions. This is part of the Student Research Symposia webinar series. And this is I think it's our fourth one on writing conclusions. We have two more after this. But if you would like to ask a question, you can raise your hand or use the chat window, and that's where I'll be monitoring. I am just introducing the webinar series, and then we actually have somebody else leading, who I'll introduce in a moment. So if you could go to the next slide, Dave. Thank you. Just as a review, the SRS locations this year are listed here, and we have 6 of them. And Dave Bydlowski, who is our host tonight, he is hosting the one in the Midwest at Wayne State University School of Medicine in Detroit, Michigan. And then we also have on the line Mike Jabot, who is hosting the one in the Northeast Mid-Atlantic, and that's going to be in Buffalo, New York. Next slide. So we have had, this is our 4th one. I was correct, yay. And we do have 2 more, making a science poster and then giving a poster presentation. And this is really, we're adding these webinars to ones that have already been done in the last 2 years. And these are just times when we have open office hours. You can ask questions, but we're also highlighting maybe conclusions that have been written for the last IVSS or SRS, or last data from the past SRS and IVSS. So we really try and bring into, we really try to bring in examples from last year and from other resources to demonstrate how that can be used in the current Student Research Symposia. So next one. And we do have quite a few resources for students and teachers. They're all on our website. And we have a page for each of those practices. And then we have resources that have to do with those particular practices. And the practices that we're talking about are generating good research questions, analyzing data, etc. Next one. We also have a teacher hotline, and we have, I believe there's 8 teachers that we have who have signed up to be part of the hotline team. And these are teachers who have done the SRS before and have offered to be a resource for other teachers that have not brought students to an SRS before. And they range in grade level and in also subject area. So if you have a question, we have a short Google form, you fill that out, and then these teachers have offered to give you a call within 48 hours and just ask your quick question, or they may email you, either way. And it's just hopefully another resource for you to connect with another teacher who's done this before. And the next one. We also have a teacher listserv, which is hopefully where a lot of you heard about this. If you're not on the list, then we really welcome you to sign up. We make sure we put deadlines in there, and it's current information about what's happening, or also resources that may help you to carry out research with your students. Next one. This is my last slide, and also Dave's first slide. I'm going to introduce Dave Bydlowski, who has been with Globe for several years. And I think I'm being nice when I say several, Dave.
Very nice.
He's also part of the RM project, which is a great project funded by NASA. He's a Globe partner in the area of Detroit, Michigan, doing great outreach for teachers and programming for teachers, and has been just doing great work with Globe. And he is an expert in NGSS as well. So I really value his experience in that. So he'll be relating a lot of this to NGSS. And so with that, I'm going to leave it to Dave. He's also a great sports fan. And I don't know. I just want to say that from Patriots Nation, where everyone hates our team, go Pats.
Oh, yeah. Go Pats.
That's a rough introduction right there, I'll tell you. But I will say we're getting one of your coaches soon. So you know that Patricia is coming to Detroit after the Super Bowl.
Well,
so
maybe you have a chance of beating us then.
Yeah, maybe. Hasn't happened in my lifetime, but actually it did long when I was just a child. So, but it's nice to be here. And just like you're from Patriot Nation, I'm from Red Wing Nation. So I'll be going to a Red Wing game tomorrow, looking forward to it. But it's a pleasure to be here for the Globe Research Symposia. And if anybody has any questions or comments about writing conclusions, please either raise your hand or interject. Very informal. I'm sure many of you are very successful in the idea of writing conclusions and working with students. So I just wanted to share some thoughts that I've had and maybe raise some questions for discussion that we might have. And when I was, thinking about conclusion, one of the things that we look at is that it's an explanation for that investigation. But kids, I'm sure you've had a lot of experience, they get confused by the term conclusion. What does that mean? And one of the ways that we've been able to maybe help kids write up an explanation or a conclusion better is using CER, or claim, evidence, and reasoning. And that's why you see it there, that claim plus evidence plus reasoning equals explanation. And I'll try and share a couple of examples of what that looks like if you're not familiar. If you are familiar, please, again, feel free to share your thoughts on it. But the whole idea is to make it a little bit clearer for kids to write an explanation for their investigation. How can they explain it to somebody else? And I think a lot of times when kids write a conclusion, they're not so much thinking about that they need to explain that to someone. That's really what that written word is all about. And but one of the other pieces is the correlation to the next generation science standards. How important is conclusion? So what I did want to do is to kind of share a few places where you would see conclusion. And in the next generation science standards, there's the 8 science and engineering practices that are one of the 3 fundamental components of the next generation science standards. And so what I did when I went to the standards, I actually went to the appendix, which focuses in on the practices and looked for conclusion. And practice 1, which is asking questions, one of the things that they refer to is that you draw a conclusion from a scientific investigation or from a model. And that's almost the starting point, that when we work with kids, we talk about kids need to ask questions, and we're going to find answers to those questions. But when you ask a question, you'll eventually draw a conclusion, and that's going to come from our scientific investigations. Well, practice 3 is referencing investigations. And so what kids are going to do is that they'll design some action, some course of action, and during that plan, that action that takes place, they will find evidence to support the conclusion. And that conclusion is all based on that question that they started with. But if they don't have an investigation, it's really not part of science. That's part of science, is to come up with this investigation. But the reason for the investigation is to get evidence or data. And the reason for the evidence and data is to support a conclusion. The 4th practice of the next generation science standards is practice 4, which is on data. And as I mentioned before about that evidence, data is the evidence, and it's the data that supports the conclusions. And that's why kids are doing investigations. And I guess one of the things that we look about in our own classrooms a lot of times is that if kids are just doing investigations, but they're not really asking a question, they're really not collecting much data, it's very difficult for them to write conclusions. But then as the next generation science standards practices go on, they really start kind of breaking this down into middle school and to high school. And practice 5, which gets into mathematics and computational thinking, it's, I guess it's kind of obvious, but it's that mathematics of the data that we're going to use to support our scientific conclusions. And that's why, especially in a project like GLOBE, where we're collecting data and we're inputting that data into the GLOBE database, that's the mathematics that we're talking about. And the mathematics is going to support our conclusions. The practice 6 deals with explanations. And if we go back to the very beginning, is that a conclusion is an explanation. So when we look at it, MS stands for middle school, HS stands for high school. And it's interesting that when we look at the elementary next generation science standards practices, they generally refer to coming up with an explanation rather than a conclusion. The first couple, practice 1, 3, and 4, mention conclusion. But after that, they're generally found within the middle school and the high school sections of the practices. But in middle school, scientific reasoning shows that or why that data or evidence is adequate for the explanation or conclusion. We keep going back to that explanation conclusion, and I think that's an important point to keep driving back with kids, the idea that a conclusion is an explanation. But how do we determine that explanation? Is it a good explanation or conclusion? Well, there has to be some reasoning that takes place, and that reasoning shows why data that they collect is adequate. So that's in middle school. But in high school, they just change it a little bit. That scientific reasoning or referencing theories and or models links the evidence to the claims to assess the extent to which the reasoning and data support the explanation or conclusion. So that's one of the things about the next generation science standards is it's nice to look at the progression from middle school to high school. What are we looking for with a middle school student? What are we looking for with a high school student? Both of them are working with explanations or conclusions. But in that middle school, focusing more on scientific reasoning, showing why the data is adequate. When we get to the high school level, not only scientific reasoning, but theories and models are going to link evidence to the claims. And we keep seeing those terms too when we talk about CER, the claims, the evidence, and the reasoning. And those terms keep showing up in the next generation science standards. The seventh practice is arguments or argumentation. And so I just showed the graphic there of a couple of people having a discussion. I think that's what we get at, rather than very often, as kids might often think of arguments or argumentation as arguing or yelling at each other. Here, what you really want to do is when we look at a conclusion, is people should be able to critique the work that students are doing and find out if there's any conflicts or contradictions within a conclusion that it might, as you get those critiques and you discuss it, you have arguments that take place, it's really probing that reasoning and evidence, and you're challenging people. And that's one of the strengths, I think, that when we see at the student research or student research symposiums, is that students have the opportunity to share what they've learned, and as we'll see in the next one, communicate information. But they've also gone through that process of argumentation, that if somebody asks them a question about conclusions, that they've already had some discussion, they've been challenged on it, they've critiqued it to see if it's a valid conclusion. But practice 8 here of really communicating that information or evaluating the information, obtaining more information. And that's why in middle school, you'll notice that students really need to refer to scientific and technical texts and kind of compare their work so that you evaluate their conclusions. So does the scientific and technical text, do they support it? Do they differ with what they're saying? And also in practice 8, to read critically at the high school level scientific literature. So that way they help to better understand the conclusion. I think a lot of times in science, we write a conclusion and then move on. What we're really looking at here, I think in the Student Research Symposium, is that as students come up with conclusions, that they then start doing some more research so that when they communicate it, they can understand how this compares to work that's been done previously. So with that, if that's okay, Jen, maybe I'll just kind of pause, give people a chance to think for a second, or see if anybody has any comments about this connection of conclusions to the next generation science standards. Well, I'll assume with the silence, either everybody's on mute or there aren't any comments. But again, please feel free to share any thoughts that you might have. So if we look at the claim, evidence, and reasoning, that's the process that I'd like to spend a little bit of time on now. And again, as we review from the beginning, that if a conclusion is an explanation, how can we help students to write a conclusion? How can we help them with their explanation? And CER is that format. That's that format about writing about science. And it helps kids think about that data that they've collected, organize it, and put it into a manner that's reasonable. And so if we look at claim, defining claim, evidence, and reasoning, claim is that conclusion about a problem. It answered that question. Our original question in that science investigation is answered through a conclusion, or in this case, called a claim. In terms of evidence, evidence is scientific data that's discovered through that investigation. And the data needs to be appropriate, needs to be sufficient. And those are going to be some of the challenges that we see later on in this presentation. So we have the claim, which is the conclusion, which answers our question, but the evidence needs to support that claim. And finally, reasoning. Reasoning is the justification to show why that data supports the claim. And then it also includes any other scientific principles that are important to refer to. So what's interesting about the CER is that a lot of times when you see it, I think people think about, well, you do the claim and then you do the evidence and then you do the reasoning. But if you look at it, claim is that conclusion. And if, in order to come up with the claim, the very first thing, of course, that you need is the question. But then you collect that data, and that data allows you to begin with the conclusion or writing that conclusion or claim. But you need to show and think about why that data justifies your work, and also to do a little more research with it. I think just in those short definitions, you see that real close connection to the next generation science standards. But you see that really it's almost a little bit backwards, that we need to collect evidence. We need to do reasoning before we write our final claim. Yet the claim can be written, and then maybe we need to review it again through more reasoning or more data. So I used for an example here, Eric Brunsell, and some of you may know him, University of Wisconsin-Oshkosh. He had a nice article that he wrote in Edutopia, and it was simply one of, is air matter? And this is what he said. He said that the claim is air is matter. And then he looks at the evidence, and the evidence is that we found that the weight of a ball increases each time we pump more air into it, like a basketball or something. And the reasoning is this shows that air has weight. And one of the characteristics of matter is that it has weight. So if you look at that in and of itself, the claim, the evidence, and reasoning, it all seems pretty good. Except that one of the problems that occurs is that there's really not a lot of evidence. And if you were coming up with a rubric for, how much evidence do you need, that becomes a challenge. But the other thing is that they didn't mention the other characteristic of matter, is that air takes up space, or that matter takes up space and has weight. And so I think what Eric is bringing up in this article is that students can write a real nice conclusion, and they can use the CER process. But then there can be problems with it. As we help students along, how can we help them discuss the evidence, look at their evidence, see if it's a reasonable amount of evidence, and then also, are they looking at all of the principles that apply? So one of the tools that he shared about how can you help students with this process and in this whole science investigation is to have kids think about, why would a scientist even do any of this work? When you're doing an investigation, why would you even do it? And one of the reasons is because scientists are curious. And I think about that, and it makes me think of the book Lifelong Kindergarten by Mitchell Resnick. And one of the things that he talks about are the 4 Ps. Give Ps a chance, is that students work on projects with their peers because it focuses in on their passions and they do it in a playful manner. Well, I think a lot of this is here, is that scientists are really interested. They want to do a project. They're passionate about that project. They need to work on it not just individually, but with their peers, and they have fun doing it. So I think that's an important idea for students to have. And then if you think about what are you curious about, or what are scientists curious about, and what might you want to investigate, is what kind of data could be collected that would deal with this curiosity. So I might be curious about something, but if I have no way of figuring out how to collect any kind of data, how can I do an investigation? And then one of the other tools that might be helpful is, how does data help scientists make claims or answer their questions? So if we can think about something that we're curious about, or think that scientists are curious, and then they think about, well, how can I collect some sort of data? And then will that data really help me draw some sort of conclusion, which would be answering my question? But the same thing is true for the students. Are you curious about something? Can you collect data about that something? And if you do collect that data, does it help you answer your question? And so, as just a couple of tips of focusing in on data is that students really need to look at the data that they collected. And then the claim, what does the data show? Evidence. What evidence does the data provide? And reasoning, connect the evidence to the claim. So if we look at data, if we focus in right now on data, our claim is telling us what data shows us. Our evidence is what did the data provide? And why does this answer our question? And finally, the reasoning is connecting the evidence to the claim. And maybe a good example of all of this is a crime of some type. And you think about, very often, we try and figure out, why does a crime, why is it committed? Who committed the crime? Or we watch a TV show and we try and link that all together. And I think that gets to the idea is that we make a lot of claims, but we hear it in the court system is, does the evidence and reasoning support the claim? And so in a crime scene, we're looking for evidence, but we're also looking for reasoning which supports that claim. So it keeps going back to that data. So that might be another way that it helps students kind of think about CER and thinking about conclusions and claims, evidence, and reasoning. So with that, maybe I'll stop again for just a little bit of time and see if anybody has any questions, or particularly if you have any comments from your experience or thoughts about any of this, focusing primarily on CER.
So feel free to unmute yourself and ask a question, or type it up in the chat box.
Well, at this point, I'll say that, again, it sounds like you don't have any questions, and we'll move on. But again, if you have any, please feel free to jump in. So as we look at all of this, what are some of the challenges? And particularly if you're thinking about providing, for instance, a rubric or something for students, a lot of discussion needs to take place. I've seen a lot of rubrics that will say, in order to, if you do like a 3-2-1 rubric, that 3 does this, 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 but then 2 is not quite as good, or 1 is not quite as good, and they really don't say what. So the questions that I think you need to deal with kids, some of them, is how much data really is sufficient. We often hear that you need to do an investigation 3 times, but a lot of the kinds of investigations that we're talking about are not just kind of a 3-time collection sort of thing in an investigation. How much data do you really need? How often are you going to be collecting data? And then another question is, how appropriate is the data? You can collect the data. Does the data really have anything to do with the question or your claim, conclusion, or explanation? And then, is your claim accurate? Are you asking people? Are you looking things up? Is your data correct? It's just because I always remember one of the examples that I've heard many times, because I saw it in science fairs, and tell me if I'm wrong on this, but it's the battery thing. Is that I don't know how many kids I've seen do investigations dealing with batteries, and batteries always work better if they're kept in the refrigerator, yet I've never seen a report come out from a battery company saying to store your batteries in the refrigerator. But I think everybody says it enough that everybody believes it, and you do some simple investigations, collect some data, maybe it supports that. The other one is the claim complete. Did you really answer your question completely? Also, how appropriate is the reasoning that's used? How sufficient is the reasoning? Kind of like, I think that one kid in the Errors Matter did a nice job of going back to the characteristics of matter, but not all of the characteristics of matter. And then, does the reasoning relate to the claim? I mean, when you look at your data and you start getting ready to write your claim, I put in there, therefore, do they relate to one another? Because sometimes they don't. And then, are students looking at scientific principles? Are they looking at what, because that's one of the things that the practices, when I talked about the next generation science standards earlier, are not in and of themselves separate, but are part of the performance expectations. And so when students are doing work, they certainly want to look at the scientific principles involved in the investigation that they're doing. So one of the things that I looked at, in looking at some sort of statements, I don't know if you're familiar with realsciencechallenge.com. It's pretty neat because I like how they work with folks, is that if you see something that you like, you can get more information. You have to give them your email, and then they send it out to you, but it gives them a chance to kind of evaluate and see if people are using their resources. But these are some of the statements that they refer to on this site. And for instance, that red jelly beans are the best ones. Television is the best invention of the 20th century. Would kids say that? Gas prices are lower in developing third world nations. Tea is the most popular drink in the world. Taylor Swift is the greatest performer of all time. And chicken soup is a good remedy for a cold. Well, are these really good claims or conclusions? And so what I've shared with you on this next slide is they actually share the claim, evidence, and reasoning. And I did the first one on red jelly beans, and I don't know if you agree or disagree. It would be hard to disagree, I guess, with red jelly beans, because I do find them that I like them the best. But that's my impression. But what was the evidence that was used? And as they said, they could give a survey, and they could see what color jelly beans people prefer. And if the first survey showed that more people liked red jelly beans, then that would support the claim. Or you could ask jelly bean companies for their annual sales numbers. If the numbers showed that the color purchased most is red, this would support our claim. Both ways to collect data. And as a person who's doing the investigation, the claim is right on the money. You know, they're saying red jelly beans are the best. They've collected evidence. Seems like a pretty good method. They've used either a survey or they've checked with companies that make them. But here's where that reasoning comes in. And that is, people may prefer red more than other colors because it represents love. People may prefer the taste of red jelly beans, and therefore most red jelly beans are purchased. Now, that's all of this is assuming that red jelly beans are flavored, and they may not be. Red may stand out to the human eye more than other colors. So if that was the case, more red jelly beans would be eaten since because they're the first to be seen. Also, maybe more red jelly beans are purchased yearly because of holidays that use red. So the popularity of red due to the marketing of the holiday seasons, Valentine's Day, and so on. So I think what's nice about this is an example with kids. And like I say, if you visit the website realsciencechallenge.com, and if these are any of them, you can contact them and they will send you all of the CER for each one of those. And there's a few more that exist as well. That it seems like a reasonable claim and it seems like reasonable evidence, but when you start reasoning it out, you start kind of challenging your evidence and start challenging your claim. This is another one I thought I would share, and that's the Ig Nobel Prize from Harvard. And that's a pretty neat one there, improbable.com/IG. And so they do make people laugh, but they ask questions and they collect research, and then they give an award for the one that, you know, kind of makes sense. And so here's what we had. Michael Smith in 2015 wrote this research question. And his question was, which part of the body does a honeybee sting hurt the most? So this is his claim. His claim is the nostril is the most painful location for a honeybee sting. The upper lip is the second most painful. So here's what he did. In order to gain the evidence, Mr. Smith stung himself with honeybees. And on a scale of 1 to 10, he noticed stings at the nostril and the upper lip had an average pain rating of 9 and 8.7, respectively. So here's his reasoning. He then did the reasoning. And he said that first, pain is more intense, he found out, at locations with thinner skin. Secondly, the reaction to pain is greater at important body locations like openings, like the lips and nostrils, for protection. And then third, measured neural activity showed an increased sensitivity at thumbs, tongues, lips, and digits. So this was the reasoning that he went through to support his evidence to make the claim that he made. So that's another example of CER. I'll stop again at this point, and then the next slide that I'll go to is to look at some of the claims that took place. And, you know, with many of these examples, maybe you can tell me what you think of CER when we look at the GLOBE claims that came from previous investigation students have submitted. So let me pause for just a bit. Okay, it looks like no questions. So let's take a look at some of these GLOBE conclusions. These are some conclusions that I read on investigations and kind of wonder what you might think about these. So this one is about tracking air quality by using lichens. And so this is what the students said. By looking at our experiment and the measurements we did, we can conclude that the air quality has not changed. It may have changed, but the change is so insignificant that we weren't able to notice the change. And as you listen to that, or as you read it, does that kind of get to what air quality, you know, what is the air quality by using lichens? And I don't know if anybody has any thoughts on that at all. All right, so let me show you one where we step it up a little bit. And here was one on changing the breeding ability of mosquitoes due to climate change. And so we're looking at kind of looking at their conclusions. The other one's kind of like a conclusion, and it's from their conclusion section as well as this. Now, so here we have usually female mosquitoes are laying about 100 to 200 eggs for one time, but it depends on the proteins, which are most important for the nutrition for the eggs, and it's reduced when the nutrition is less. Again, we're going back to breeding ability of mosquitoes due to climate change. Secondly, they have mosquitoes are cool-blooded arthropods. And I think insights, but we're, you know, as we're looking at all of these, you know, the students wrote these, so I tried not to change doing it, just a few grammatics. Next, mainly, they lay eggs in low temperature, and sometimes it departs due to urbanization. Their ability to breed also increased when the temperature is getting low. With this fact, I believe it's dengue, correct, or the mosquito infected patients are also increasing in low temperature. And then according to the research, we consider that when the climate changes, mosquitoes' life cycles adapt to it. And I think what you see here is that students are trying to use more reasoning as they write their conclusion. And then another example that we had was comparing the soil in different ecosystems. The results clearly show that the forest soil has a lower pH compared to the heather soil as we expected. This shows the amount of decomposition has a big influence on the pH of the soil. This becomes even more clear when comparing the top layer of the forest with the other two layers of the forest. The pH on the top layer is a lot lower than on the layers below. These 2 points prove that more decomposition of organic material results in a lower pH of the soil. The different soil layers of the heather seem to have quite a similar pH, especially compared to the forest soil. This is because there are less plants causing less decomposition. The small difference between the layers is probably influenced by feces of animals, causing the soil to become more acidic at the top layer. And as I look at that result, one of the things that I think about is, as if you were there as a reviewer of a student research project, one of the things that we might think about is CER as we do that for looking at our review of the project. What is the claim, and how does that evidence support the claim? And then, do they provide reasoning which shows the connection of the evidence to the claim and that the claim is a valid claim? So with that, that hits most of the point. Well, it hits all of them because that's what I put in the presentation. All of the notes that I had for conclusions. And I hope that as you look at it, that you see that connection with conclusion and evaluation. Secondly, that the connection to the next generation science standards. And also that CER helps students to write their conclusion by looking at the claim itself, by looking at the reasoning, and by the claim, the evidence, and the reasoning. So with that, I'll stop and see if you have any questions or any comments, and turn things back to Jen.